Drew Heinig, the physics guy. Drew.
Hi, my name is Drew Heining, the physics guy, and today we will be figuring out if yellow lights are timed correctly in Chicago. Working on this with my partner, Ethan Chung.
Hey guys, it's Ethan Chung.
In order to start, we need to find information about yellow lights in Chicago and how fast the cars are going.
Walter Payton College Prep.
I'm about to enter the physics lab.
Excuse me, sir. Can you help us with the yellow light problem?
Yeah, sure.
What's your name?
John Edward Stokes.
Nice to meet you, John Edward Stokes.
So, unless otherwise indicated, we know that the speed limit is 13.412 meters per second, or 30 miles per hour. And then, according to our research, the yellow light lasts for 3 seconds.
With this information here, we can determine if yellow lights are timed correctly. See, there are two scenarios once the light turns yellow. The car can stop or the car can go.
There's also an area called the dilemma zone in which the car won't be able to stop safely, and it also won't be able to go through the light at the speed limit before the light turns red.
Know what the dilemma zone is in order to understand how long the yellow light will be.
Well, we know that the car is traveling 13.4 meters per second, and the intersection is 32 meters long. And also an important factor is that the car is 4.63 meters long. So in order to find how far the car can travel within the time that the yellow light lasts, we have to multiply the car's velocity, which is 13.4 meters per second, by how long the yellow light lasts, which is 3 seconds. With this, we get 40.2 meters. So the car can travel 40.2 meters within the 3 seconds that the yellow light is active. So to find one end of the dilemma zone, we need to find the distance that it needs to travel. So part of the distance that it needs to travel is 32 meters, which is the length of the intersection. And for the car to be considered past the intersection, the back of the car needs to be on the other side. So the length of the car is 4.63 meters. So add these two together, and that is the distance you need to travel. So right here, we have that. The length of the distance that the car needs to travel is 36.63 meters. Subtract that from 40.2, and you get 3.57 meters, which is one end of the dilemma zone.
We can also calculate how far the car needs to be in order to stop at the stopping line safely. We have our equation right here. Now all we need to do is plug in the number.
With this equation, we can now figure out how far the driver will travel after they put on the brake. So the negative acceleration of the driver is 3.4 meters per second squared times the time, which we have to factor in human reaction time, and the average human reaction time is about 1.5 seconds. So the initial time, which is 3 minus the 1.5 seconds, equals 1.5 seconds. So that's why we have 1.5 seconds squared here, plus the initial velocity, which is 13.4112 meters per second, times the time again, which is 1.5 seconds. So I know that this equals 16.2198 meters. However, we also need to factor in the 1.5 seconds before the human puts on the brakes. So in order to find this, we'll do the average velocity, which is 13.4112 meters per second, times the time, which is 1.5 seconds. 1.5 seconds, and this equals 20.1168 meters. So now, in order to find how far the car travels in that 3 seconds when the light turns yellow, we add these two together, and this equals 36.406886 meters.
So from this, we can calculate the dilemma zone by subtracting this from the start of the dilemma zone, which was 3.57 meters. So 36.4086 meters minus 3.57 meters equals 32.8386 meters. and that is the dilemma zone.
We're here at the corner of LaSalle and North Avenue, analyzing the speed of the car.
It looks like the cars are going a little bit over the speed limit.
My app tells me that the cars are going 32.5 miles per hour, even though the speed limit's only 30 miles an hour.
I guess we should measure the delimit zone of the cars going 32.5 miles per hour, since the whole point of our project is to keep the cars and the people in the cars safe.
So we're back here at Walter Payton College Prep because we have a new problem. Hey, Jedwards, what's up?
What's up?
So we have a new problem. We found that cars are actually traveling faster than the speed limit. And would you be able to help us out with that?
No, I'm kind of busy right now, but I can get my assistant, Luke, to help you.
Oh, hey, I'm Ethan. Nice to meet you.
Nice to meet you, I'm Luke.
And this is Drew, the physics guy.
Nice to meet you, Drew, the physics guy.
Okay, we are back here because we have found out that cars actually travel 32.5 miles per hour or 14.5288 meters per second. So because the cars travel 32.5 miles per hour instead of 30 miles per hour, we need to find the new delimit zone for this new speed that we have just found.
So for this new speed, we can figure out how far it needs to travel. So first, again, we have to take its velocity times the time that the yellow light is, and that way we can figure out how far that it can travel during the yellow light, which is 43.5864 meters. Then we have to figure out how far it has to travel to make the yellow light, which is the length of the intersection plus the length of the car, which is adding up to 36.63 meters. Then we have to subtract the length that it has to travel from what it can travel in that time. Then we get 6.9564 meters, which is how far it can be from the start of the intersection when the light turns yellow, if it's traveling at 32.5 miles per hour.
Oh, so we can use the equation we used last time. X final equals 1/2 t or 1/2 a times t squared plus the initial velocity times t plus the x initial.
Okay, so I plugged all the numbers into the equation. So x of f equals 1/2 times negative 3.4 meters per second squared, which is the acceleration, times 1.5 seconds squared. 1.5 seconds is t because the yellow light time is 3 seconds and the human reaction time is 1.5 seconds. So they have 1.5 seconds to decelerate. And then plus 14.5288 meters per second, which is the velocity that the car is traveling, times 1.5 seconds. And that so x of f will equal 17.9682. Now we have to factor in the human reaction time to this, so we have to do 1.5 because 3 minus 1.5 equals 1.5, and that's what we got for human reaction time. We have to multiply that by the speed that the car is going, which is 14.5288. So then for that, we get 21.7932 meters. So then we have to add the human reaction time, the distance that they travel when they're reacting at the same speed that their velocity is, plus the deceleration distance. So this plus that gives us 39.7614 meters.
So we now know the start of the dilemma zone, which is 6.9564 meters, and the back of the dilemma zone, which is 39.7614 meters. So the way to find the dilemma zone is you take 39.7614 meters and subtract this by 6.9564 meters, and this equals 32.805 meters. And this is the distance inside your dilemma zone.
To find the yellow light time for 30 miles per hour, we need to add the back of the dilemma zone plus the length of the intersection plus the length of the car for the to know how far the car has to travel to make it through the light if they're in the limit zone, and that equals 73.0386 meters. So then we have to divide that distance by their velocity, so 73.0386 meters divided by 13.4112 meters per second, and that gives us 5.45 seconds. Okay, to find the yellow light time for a car traveling 32.5 miles per hour or 14.5288 meters per second, we need to add the back of the delimit zone plus the length of the intersection plus the length of the car all together to find the distance that the car needs to travel. And that distance is 76.3914 meters. So we need to divide that distance by the velocity of the car, which is 14.5288 meters per second, and so 76.3914 meters divided by 14.5288 meters per second gives us 5.26 seconds.
Hi, my name is Drew Heinig, the physics guy, and after many days of hard work, we have finally found the answer to our problem. The yellow light needs to be greater than 5.45 seconds for a car that is going 30 miles per hour. For a car traveling 32.5 miles per hour, the yellow light time needs to be greater than 5.26 seconds. We would like to thank Drew Heinig, Ethan Chung, Luke Martin, and John Edward Stokes.
Jedwards!
Without them, this could not have been possible.